I'm going to be creating a basic solver now, and this is going to be a Lookat solver. Following FK, this is one of the most straightforward solvers which we can make. It is a very common control to make, and is very often used in rigging of mechanical items, with the most common of these being the turret. In a character rig, this will generally be used for a Lookat control for the eyes, as well as occasionally a Lookat control for the head, although it's very flexible and can be used for a lot of other things as well. So this is an easy control to set up. It is also a very easy solver to make mathematically, as the vector operations which you use to create this will be used all the time for basic transforms in any case. If you understand how to create a transform from two vectors, you will be able to create a Lookat solver manually. For this solver, I'm going to use the built-in Apex Lookat node. In order to do this, I'll need to have multiple transforms, so I will need to create extra controls for this solver. Essentially, instead of needing one control for the eyes, I'll need two controls for the eyes. One will be the Lookat control itself, which will be the target for the eye, which will give us the direction that the eye is facing in. The second will be an up vector. This will be used to prevent unwanted rotation, as the eyes only rotate in two axes, which would be the pitch and yaw axes. The eyes do not roll. So for this, I've created a control setup. This is essentially a similar control setup to the rig, in that we have the head and the eyes, but I now also have joints for the Lookat controls, as well as up vectors for the eyes. The up vectors for the eyes should not move in relation to the eyes, so both the eyes and the up vectors for the eyes are children of the head. The Lookat controls could be the child of the head or of the root. We're not going to be doing any space switching. We're just setting up the basic solver for now. So now I'll work on the network, and here I'll be setting up the network manually so that we can see the basic structure which we are creating more clearly. I'll start by getting an edit graph node. This will be connected to the multi-port of my packed folder. I'll set this to be the first entry. The order here shouldn't actually matter, but I prefer to have the graph first. I'll give the graph the name base, and this will have its type as rig. So essentially this is going to be the rig that I'm working on. After this we'll have our base shape, and this will be our deformable mesh. In this case the mesh is irrelevant, and it will not work with the skeleton which I'm setting up. After this we have our skeleton. The skeleton consists of our neck, our head and our eyes. This will be followed by the controls. The controls will not share the name base, and instead will be referred to as controls. These names can be changed to whatever we want them to be, but this will give me a reasonably straightforward setup, and this will cut down the number of changes which I'd need if I was using the auto-rigger, as these names will not clash with the names in the auto-rigger nodes. The biggest change which we have here is that I'm now using two separate skeleton setups, one for the rig itself, and one for the controls. I can now work on my graph. I'm going to start by using the import KineFX skeleton script in the edit graph node to bring in my skeleton geometry. This is not strictly necessary as I could build this manually, but it is easier to get our hierarchy this way. And more importantly, we'll be able to place our controls correctly if we do this, as the default positions for the controls will be set properly. In this case, instead of looking for the inputs from the skeleton itself, I will just reference the object merge nodes. First I'll get the joints for the skeleton, although these are not really necessary yet. I'll give these a color so I can identify them more easily. In my personal coloring scheme, skeletons are purple. I'll then do the same for the merge node for the controls. I'll give these a color as well, and my controls will have an orange color. Once again, the main reason for importing these this way is to make sure I have a proper default pose. If I create these manually, these will all have a default pose of 0. If I create these this way, the default pose will be set to the same position as the joints. We will also get a proper default orientation, which will make it easier for us to set up these controls. Once again, we will not use the majority of these nodes within the setup, but this will save us time for the joints which we are going to use. We can then work on the network itself, and for the network we'll need an input, and we'll need an output. We'll then require geometry. In this case we'll be dealing with geometry which will be manipulated, so I'll want to store those geometry values in a node, which will essentially function as our rest geometry. And this will be a geometry value node, and I'll need two of these, and these will be connected to my input node. These will be storing our skeleton, and they'll be storing our controls. I'll be updating these point transforms, so I'll need a set point transforms node. We'll need two of these as well. We'll need one for our skeleton, as well as one for the controls. I'll connect this to my first branch, and this will set the first port of my output. The second will be connected to the second branch, and then to the second output port. I'll then want to update the inputs. I'll start with base.skeleton. I'll want the input and the output to match. So the first input will be base.skeleton. and the first output will be for my base.skeleton geometry as well. The second input will be for our controls.skeleton. For the output, I want the second port to be controls.skeleton as well. We'll then need the joint which we're going to manipulate. So this joint will be one of our controls, and it is going to be the joint that we're going to look at. For this, we'll need to use the transform object, as this is what allows us to manipulate this joint, and we'll use this to connect our joint to the interface. In this case, I'm going to work with the left eye lookat. This node will be connected to our input, and in this case, I'll be connecting the translation of this node to the input. So this will be updating our solver, and this will be updating our base skeleton. To do this, we're going to use a transform lookat node. This will be setting the final transform of the point, so I'll need to connect this to my set point transform node for the base skeleton. This transform will be our left eye. This name must be the same as the joint which we're setting, so it will be renamed to left eye. So we've got our control where we're going to point to. We've also set up the basic solver, which is going to set up the direction for the left eye. We'll need to set the initial transform for the solver though, and this initial transform will come from our skeleton and will be set by the point which we are updating, which should be the left eye. To get this joint, I'll use a getPointTransform node. This should be the individual transform node and not the getPointTransforms node. I'll connect this to my base.scale geometry, and this will be connected after our geometry value node where we're storing the rest transform. The output transform here can then set the first input of our lookat node, which is the transform of the joint which we are setting. In the parameters for this node, I'll need to add the name for the joint, and the joint which I'm updating is the left eye. I'll then need my up joint, and this will come from the controls geometry. I'm going to specify this in exactly the same way as I've got my eye joint, so I'll duplicate this node, and this will be connected to my control skeleton branch. This will be connected to the up transform in our lookat solver. I'll update the name of this joint to left eye up. The final input here will be the transforms for the lookat, and this is for the joint which we're going to manipulate, which is the left eye lookat, and I'll set this with the transform from the transform object node. This control is now setting our lookat, but it will not actually be visible within the animate node. So I'll need to use the transforms from this control to update my geometry. The transform here will now be connected to the second input of my setPointTransforms node, and this will be the second setPointTransforms nodes, which is defining the joints for my control skeleton. In order for this to set the joint correctly, I'll need to rename the port. The port will now be left eye lookat. This setup should give us our basic control, and this should complete the most basic version of the solver. I can now test the solver to see if it will work. This is not working properly. I'll make sure that I've reset everything, and my eye joint actually is here, but it's in the wrong place. So I can manipulate the joint, which is the correct behavior, and I'll need to test if my transform is being updated. For this, I'm going to use my visualizations, and I'm exposing my transform attribute here. I am updating the transform, and it is being updated by my lookat control. There are, however, issues with the transform, in that it doesn't actually match the original transform for the eye, and is pointing in the wrong direction. So the behavior is correct, but the z-axis should be facing towards my control, not away from it. The x-axis is also facing in the wrong direction, so this is rotated 180 degrees from what I want. So I need to have my z-axis facing towards my control, not away from it. So the control is working, but I do have two major issues. I need to correct the transform, and I need to correct the position of the controls. So we can now correct these bugs. The first thing to deal with is our joint being placed in the incorrect position. This is because of me generating the network automatically. My left eye lookat is still connected to a parent and is having its parenting data set. The parent, however, is not currently connected to the network properly and is not being updated correctly. So I'll remove this connection. The second thing to set up is our transforms, and this will be slightly more complex. The mathematics of this are also slightly more complicated than I'd like them to be, mainly due to the fact that I could not find a negate node within this version of Apex, so I will have to construct the negation manually. I'll need a matrix 4 to vector 4 node, and I'm going to use this to break up my matrix into 4 vectors. I'll then need a vector 4 to matrix 4 node, which I'll use to turn these vectors back into a matrix. This node will then drive my left eye in the setPointTransforms node. So essentially we're breaking apart our transform and then we're putting it together again. I'll not be changing any of the ordering for these nodes, so they will be connected together directly. The first vector will be for our x-axis, and this will be connected to the first vector of the vector 4 to matrix node. This will be followed by the y-axis of our transform, and then the z-axis. The fourth row of the transform will position our transform. What I want to do now is I want to negate the z-axis and the x-axis. This is the equivalent of rotating this by 180 degrees in the y-axis, but it is a more straightforward operation. Currently, I've not been able to find a negate node in Apex, so we will do this manually. I'll need a multiply by vector node. I'll then need to multiply this by a float constant, which in this case will be a float value node. I'll need to multiply the x-axis by a float. I have the incorrect multiply node. I should be multiplying a vector and not a float. So I'll need to multiply my x-axis, and I'll also need to multiply the z-axis. These will be multiplied by my value, and I only need a single value here, and this value will be negating these, so the value will be -1. This will give us our updated network. So we're getting our geometry. We're then getting the geometry for the eyes and the eye controls, specifically our eye up geometry. The joint that we're controlling is our eye lookat. We're then using a transform lookat solver to update the lookat. And then I'm adjusting the transform to make sure that it is consistent with my skeleton so that I do not have problems with deformation. After this, we update the points in our geometry, and we then outputting the updated geometry. I can now try my network again. I'll reset all, and my control is now in the correct position. The eye also appears to be pointed towards the control correctly, and when I move the control, the eye should point towards the control. This gives us a basic eye control, and this will be how we set up a basic eye solver. So this is how we would set the basic network, and then we'll want to be able to script this for the auto-rigger node so that we can add the controls for the eyes to both the joints within the network.